Dear students, in the previous lesson we have learned how to work with database indexes and why they are so important for searching and working with data. The last thing that awaits us is this final lesson. We are going to focus on data searching through the so-called aggregate functions. Within our data, we can see a couple of nested documents. If we wanted to search for, let's say, the number of used products, we would have no other option but to unpack the documents into individual parts in such a way that they would get to the same level as the main document. It means that all of the information included in these superordinate documents would be redundantly duplicated. Only then we would be able to work directly with individual data. Let's take a look at how to work with individual examples using a so-called pipeline method. It is one of the methods that has been built into the MongoDB database directly. Another option is to use the inner functions of JavaScript called the MapReduce method. We can write some of our own functions to help us search through the database effectively. The third option is to use some framework for aggregate functions. Such framework should help us to prepare these functions so that they can be worked with. Because of the way they are nested, aggregate functions usually cannot be used. It is a little disadvantage, but it is not a problem that couldn't be solved. It's just a little bit impractical. We will now expand our little collection of 3 entries, and we will do so using the insert many command and adding 2 more people. So now there should be 5 entries. We are doing this so that we can show the aggregate functions better and to make addition more comfortable. Let's take a look at the aggregate functions. We are working with the LIDAR database, and we are using aggregate to search for group functions. By using the group command, we are determining the group that we are interested in. In this case, it's the average age. It will be calculated by this function here. Let's see what happens when we execute it. So our average age equals 29.2. If we are interested in the average age of each gender, we will just expand the search criteria. Let us add the attribute udaye.pohlavi. And we will learn that the average age for women is 30, while for men it's 28.6667. It is so because we have added more younger men. Using the project command, we will list the information about the number of orders that our individual customers have created. We can learn that through the size function of the objednávky document. Here, we will just list the details of our individual customers. Everyone, apparently, has 1 order, except for Tomáš, who has 2. Since our orders are divided by customer gender as well, we can use this information to learn, for example, the sum of all orders by gender. So the orders that we determine by the size function can also be summed up by the sum function for each available gender. Now we can see that men had 4 orders to them, while women had 2. The result is such because we had 2 women with 1 order each, and 3 men, of which 1 had made 2 orders. This has still been a simple approach, since we didn't need any sub-details from the document itself. If we need such details that we cannot get through the size function, and we need to search for each order separately, we will have to use the anwin function. This way, we'll be unpacking the orders. Let's see what such unpacking looks like first. For our customer Tomáš, we have a new document which has been duplicated for both the first and the second order. Since this view is still rather extensive, we will need to take a look at all these orders combined. In other words, we will need to see individual items of all orders. Now that we have requested the items of each order, we can immediately notice larger amount of data. Since a new document was made for each item, we have about 11 documents at the moment. And since documents are displayed this way, we can start learning how many items were sold instead of who had ordered them. To sum up, we have used the unwin function to unpack all of the available orders. We have learned how many products have been ordered in total. And now we are interested in what items were ordered by, for example, women. We will add the match function at the very beginning. It will filter out the details that we are not searching for. In this case, those will be the orders of men. In the same way as before, we can filter the information that we want. Now it's apparent that women have bought only 5 pieces of ubrousky and 4 pieces of tričko. Working with aggregate functions might be a bit more difficult, but we have plenty of tools like Studio 3T or Mongo Compass. These tools enable us to enter the more complicated commands in the same form as we would do with SQL query. Thanks to them, we don't have to bother ourselves with complicated entries and use their simplified form.